All right, let's dive right into this explainer and completely unravel the OSI 7-layer reference model. Before we even get into the nuts and bolts, I want you to think about something genuinely mind-blowing. Just to load this very explainer on your screen, thousands of invisible digital handshakes, translations, and precise routing decisions literally happened in fractions of a second. If you've ever wondered exactly how your smartphone or laptop talks to a server on the completely opposite side of the planet so seamlessly, well, you're in exactly the right place. Today, we're going to break down this foundational computer networking concept, and we'll do it step by step, making the invisible magic of the internet make perfect sense. So think about this. How does a message actually travel across the world without turning into complete and utter chaos? Just imagine the sheer anarchy of sending a digital message globally without any standardized rules to guide it. I mean, we're talking about billions of devices, right? Smartphones in Tokyo, laptops in London, massive server farms, IoT devices, all manufactured by totally different companies using completely different hardware, and all trying to talk at the exact same time. It's staggering when you really think about it. Without a universal agreed-upon language, a simple text message saying hello would just turn into static and get completely lost in the void. Now, what's really interesting here is the stark contrast between those two realities. On one hand, a network without rules is basically a nightmare. You get massive data collisions, lost data packets just vanishing in transit, and hardware from one company fundamentally refusing to cooperate with hardware from another. On the other hand, we have a network operating with the OSI model. Suddenly, out of all that noise, we have order. We get incredible reliability and universal standards. It's the reason a laptop made by Apple can seamlessly talk to a Dell server running Linux. Everyone is finally playing by the exact same rulebook. So, the crucial takeaway is that the OSI model, which stands for Open Systems Interconnection, by the way, acts as this ultimate universal framework to prevent digital chaos. But, you might be wondering, why exactly 7 layers? Why not just one giant set of rules? Well, the real genius of this model is its modularity. It takes this monumentally complex task of global network communication and chops it up into 7 distinct, manageable layers. Because of this, if someone invents a brand new Wi-Fi standard, they don't have to completely rewrite your web browser software. You only update the layer that needs updating. It's an incredibly elegant solution. To really wrap our heads around this, we can map these 7 theoretical layers directly to something super relatable: the physical steps of the postal mailing system. We'll use this analogy for our whole journey today. We start at layer 7, the application layer, which is just like writing the letter. Then we move down through presentation, where the message is translated and secured. Layer 5, the session layer, is opening a dialogue with the post office. Then transport decides on registered or standard mail, while the network layer adds the all-important global zip code. Data link handles the local delivery trucks, and finally, layer 1, the physical layer, is the actual roads and highways. Let's actually break each of these down so you can see how the engine runs. All right, starting with writing the letter. These are our upper layers, 7, 6, and 5. Layer 7, the application layer, is the only one you actually interact with directly, like opening a browser or typing an email. Then we drop to layer 6, the presentation layer. Think of this as getting your letter ready for the mail carrier. This layer translates the data, compresses it to fit in the envelope, and absolutely crucially, encrypts it. It's essentially writing your letter in invisible ink so nosy mail carriers can't read your private stuff. Then we hit layer 5, the session layer. This establishes the dialogue to begin the mailing session. It's basically like walking up to the post office counter and saying, "Hey, I have a package to send," ensuring everything stays synchronized while you do your business. Okay, quick prediction time. The letter is completely written, properly translated, encrypted in its invisible ink, and safely sealed in its envelope. The session with the post office is officially open. What do you think happens next to prepare this letter for a journey halfway across the globe? Well, that brings us to packaging and addressing. This covers our middle layers 4 and 3. At layer 4, the transport layer, the post office basically asks how you want this package sent. You've got 2 main choices. Do you need highly reliable registered mail where you get a delivery receipt? In networking, that's TCP, which uses a 3-way handshake to guarantee your data arrives perfectly intact. Or do you just want standard, incredibly fast delivery, like dropping a postcard in the box and just assuming it gets there? That's UDP, which is super fast and perfect for things like live video streaming. Once you choose, we drop to layer 3, the network layer. This is the global zip code. Using IP addressing, it acts like a digital GPS to figure out the absolute shortest, most efficient path to your final destination. Now we're down to the physical delivery, the lower layers 2 and 1. So, Layer 2 is the data link layer. If Layer 3 was the global GPS, Layer 2 is the local mail sorting facility and the literal delivery trucks. It uses physical MAC addresses, hard-coded onto your device like a digital license plate, to hop from one local router to the next. It also uses protocols like CSMA/CD. Sounds super technical, I know, but it's really just the equivalent of a mail truck politely checking if the road is clear before backing out so it doesn't crash into another truck. Finally, that truck relies on Layer 1, the physical layer, the literal tangible stuff, the copper wires, the glowing fiber optic cables stretching across the ocean floor, or the wireless radio waves. It just takes all your data and pushes it out as raw ones and zeros. Let's bring all this theory together into a real-world application.
Think about just loading a website. First, at the application layer, you type in a URL, which triggers a DNS query. Since computers only understand numbers, DNS acts exactly like a giant global phone book to find the site's exact street address. Next, your transport layer initiates that TCP handshake, establishing a reliable, registered mail path with the server. Finally, your data shoots all the way down the layers, flies across the world, hits the server, and climbs back up the server's own layers. The server understands it, sends the web page back down, across the ocean, and up yours. The web page arrives, you basically open the letter and read it on your screen.
So, rapid-fire recap here. We go from your intent at the application layer, translating at presentation, opening dialogue at session, packaging securely at transport, adding the global IP at network, handling local truck routing at data link, and finally pushing it over the cables at the physical layer. This whole process of wrapping your data with new instructions at every single layer as it goes down is called encapsulation. It's like putting your letter in an envelope, tossing that into a giant canvas mailbag, and loading it into a truck. It is the absolute heartbeat of computer networking.
We've covered a massive amount of ground today, pulling back the curtain on something we all use constantly. But as we wrap up this explainer, if you remember only one thing, it should definitely be this. The 7-layer OSI model is absolutely not just some dry textbook theory. It's the vital, working blueprint that literally prevents total disaster in our connected world. It's the unsung hero allowing you to stream video, send emails, and browse securely, completely regardless of what device or network you happen to be using. It truly is the ultimate global digital postal system.
So now that you understand the rules of the journey, which specific layer of this digital postal system are you most curious to explore next? Do you want to dive into the invisible ink cryptography of the presentation layer, or maybe the mathematical magic of IP routing at the network layer? Keep that curiosity alive, and thanks so much for joining me for this explainer.